aircraft is needed to transport food from Montreal to London and back. 35 tons of perishable cargo valued at $1 million is to be carried. However, the airplanes depreciate quickly, 20,000 Canadian dollars per hour. But one cannot simply maximize cruise speed because it increases fuel consumption. Therefore, we face a dilemma: high speeds or fuel consumption. Also, we need to minimize the production costs, development time, and environmental footprint. Knowing all the variables that must be optimized, what aircraft is the most effective for the mission? To the jury, we propose an optimized Airbus A310-200F geometry.
Okay, so hello everyone. So we're from the University of Sherbrooke, and for the next 15 minutes we will be presenting you our new cargo aircraft concept, and this is the COZ Cargo. So as you might be aware, aircraft manufacturers are constantly trying to improve the quality of their aircraft to better satisfy customers and airlines. And so to remain competitive, they have to design their aircraft in a way that is most profitable for the freighting companies. With the fuel prices that are constantly going up, this means that the economic quality of the aircraft are increasingly dependent upon fuel efficiency. And so fuel economy will be a major criteria in the future for aircraft, especially transportation aircraft. So with that in mind, we're ready to start the presentation. And if you have any questions or simply you think our English is bad, you can tell it at the end. So the presentation is divided into 4 main sections. So first of all, we'll tell you about the design philosophy we adopted, and then we'll tell you about the baseline design we used, and the improvements we brought to it. Then the performance and gains we got by improvements, and finally the financial aspects of the aircraft. Okay, so basically mission requirements is to have a range, well, at least the Montreal-London distance, which is 5,200 kilometers. And with that, the maximum cargo weight is 35 tons. And yeah. So the design goal we had was, first of all, to meet the mission requirements. We also want to minimize the operating costs, because basically that's what decides whether our airplane is bought by airlines. We also want to minimize the environmental footprint because of sustainable growth, but also because it plays a major role in obtaining airworthiness certificates. Finally, we want to use technologies that will be available and ready for use in 2025. So the aircraft manufacturers usually produce 1 or 2 new models of aircraft every decade, which means that when they design an airplane, they have to think in the future and see what technologies will be available. If they don't, and they just use currently available technologies, well, their airplane is going to be obsolete the day it enters service. If they're too optimistic, then they will have to do major redesigns, and that's not a good thing either. So yeah, so we try to only use technologies that we think will be ready for use in 2025, as I said earlier. So one of the main dilemmas that we had was to decide whether we should go fast so that the cargo doesn't depreciate much, or whether we would go with a slower but more fuel efficient one. And so, so basically we had to make a choice, and that's what I'm going to explain in the next 1 or 2 minutes. So with many calculations, we came up with this plot, which basically tells you the operating costs as a function of the efficiency and speed of the aircraft. So as you can see, we want to get as close as possible from the bottom left of the block. So we took a few existing aircraft and we put them in the plot of efficiency in function of their cruise speed, and you can see a clear distinction between the supersonic aircraft and the fuel efficient one against this supersonic but poor efficient one. So yeah. So we abandoned the idea of the supersonic design for 2025 because we don't think that the technologies at this moment will enable us to reach the design goal we fixed earlier. So yeah. So there's a lot of reasons why we abandoned supersonic design. Noise pollution, flying in the ozone layer, thrust, fuel consumption too high. So we'll go with a subsonic design. So we started with an Airbus A310 because it pretty much had the performance that was required for the competition, and we brought improvements to it. So the first improvement was to select a new engine, and these were the main choices that were available for 2025. Okay. So finally we ended up using the Ultra Fan from Rolls-Royce because well, we thought it was the best engine at this moment, considering the well, what we wanted to do with the engine, and it's supposed to enter in service in 2025. So it's yeah.
Here are the improvements for the structure. We want the majority of the plane to be made of unidirectional carbon fiber. Why? Because the strength to weight ratio is bigger than metals, common metals. Of course, our plane will be made of improved 25 metals like steel, titanium, aluminum. The absence of fenestration will increase the strength of the plane, and we want the optimization of the fiber direction and thicknesses to be done with new design metals as per black aluminum. So, yeah. For the packaging, the loading will be done at the nose of the plane because the pallets are very long and the actual doors for loading are not enough long. There is rooms for 10 M2 pallets on the upper deck and the lower deck. Basically, we could only have 3 pallets if it was only made of water, but with the 7 extra pallets, we can afford a large diversity of product density. So like eggs, it's lighter than water. So we have margins. The improvements for the fuselage, we want to add tiny holes and sweeping jet actuator to smooth the airflow and improve the fuel efficiency. The fuel weight savings can reach 1 or 2%. For the electronics, everyone knows about the fly-by-wire, but we renew the fly-by-light, which use the concept of optic fibers to send the signals. And we want to reduce the hydraulic systems to a more electric aircraft to reduce weight again and to have a safer mechanism. And the last improvement is the manufacturing method. Like we want to use a lot of composite. The fuse weight and the fuel weight will be reduced about 10%. But is this doable? So we count on the improvements of actual robotic system and specialized molds for fiber lamination to do that. And using an existing aircraft and an existing undercarriage will reduce time for the development of our aircraft.
Okay, so we're at the third part, which is the performance and gains the improvements brought us. So basically you can see that we met the design requirements with the payload of 35 tons that we can support, and also the range, which is higher than the distance from Montreal to London. We plan the margin in case the airplane has to deviate from its path. Yeah, so also it goes a little bit faster than the Airbus 310, and that's because we want to stay subsonic, but also to decrease the depreciation of the cargo. So for the fuel consumption and environment, most of the improvements come from the engine, with a 30% decrease in specific fuel consumption. And then we have the advanced composite structure that bring us a supplementary 10%. And then the fly-by-light, tiny holes in the aft fuselage. So we get an overall 40% decrease in fuel weight. So, yeah. About the financial aspects, so you can see that since we go, well, we're still slower, so we're still slow, so this means that most of the operating costs come from the depreciation of the cargo. And for a round trip to Montreal, Montreal-London, this means a $240,000 loss, which is a quarter of the value of the cargo. Yeah. So basically that's for a freight company that would wish to buy our airplane. So the total cost, development cost of the airplane is roughly $5 billion. And the aircraft itself will sell for about $250 million. And yeah, so with this, freighting company that would wish to buy our aircraft and will reimburse itself in less than 4 years, we estimate. So in conclusion, we've met the mission requirements. We've minimized the operating costs by choosing a slower aircraft rather than a poor efficient one, but a much faster one. We minimized the environmental footprint by reducing by 40% 100% the fuel weight necessary to accomplish the mission. And finally, we used only technologies that would be available by 2025. So we hope you enjoy our presentation. And yeah, so if you have any questions, ask us now.
Sherbrooke team. So we have now 10 minutes for the judge, so feel free for any question now, gentlemen.
Can everybody hear me? Yeah. First of all, well done, University of Sherbrooke. It was very, very interesting. Thank you for your presentation. It's good to see that you're including references to your source material as well. It's something that I'm always banging on as students back at Swansea to do, so you've done that, so well done. You say your starting point for this aircraft is the A310, and most of your improvements you're getting from the Rolls-Royce engine. So you put a lot of trust in these guys. You didn't, which is not necessarily a bad thing. And I think it's probably wise that you ruled out the supersonic option. I wish that was a consideration we could have relaxed on the Bloodhound project. That would have made our lives easier, but we can't. But I think that's probably wise. You didn't talk about any potential aerodynamic improvements that you could make to the A310. I wonder if you have any thoughts about that, because you did mention that you were going to try and operate this aircraft at a slightly faster cruise speed than it's designed for, so I wonder if you considered at all any potential aerodynamic improvements that you could make.
Well, we did consider it, but we tried to mainly focus on the engine. I guess we could have done something, but we thought that the lift-to-drag ratio was sufficient enough, so we could basically want to do what we plan to do, but for sure we could have done some aerodynamics changes. But I hope this answers your concerns.
Presentation, although we didn't get to see it, though I was following you there a bit at a 45 there to be able to see what was going on, and following on my on our presentation, our hog copy. I guess my first question is why the 310? Why the Airbus 310?
Mainly because when comparing the specs of the aircraft, we found out that given the mission requirements that we were given, the A310 accomplishes roughly the same thing. It has a payload capacity of 33 tons. We were required to do 35, and the range is about 5,500. So yeah, but afterwards we found out the Boeing 757, which was more fuel efficient one. But then it was loaded too late, and so yeah, the 757 would have been a better choice, but we still went with the A310 because, yeah.
Have you considered replacement costs in terms of maintenance, in terms of repairability, maintainability? I looked at your presentation, and there wasn't anything really in there in terms of what airlines or what the airlines are using, what the repair costs are. It's fine and dandy when you're purchasing an aircraft and you get an upfront cost, but then when we look at the recurring costs, that's where the operators are really suffering. That's where most of your savings or most of your costs are going to be. Have you considered that?
Yes, we've considered that. Actually, we didn't talk about it because we thought we would explode the time of the presentation, but we planned $40,000 per mission buffer for maintenance costs, and also with advanced composite, it would cost roughly 16% less than maintenance than it actually cost. So we've taken that into account, yes.
And I guess my last question, in terms of airworthiness, I didn't see anything in there for airworthiness. How do you plan on certifying this? In terms of certification plan, normally when you're getting into modification of this size of this magnitude, you're looking at airworthiness. Airworthiness is definitely if your Transport Canada, YASA, or the FAA decide that this is not going to fly, then it's not going to happen, no matter how good your idea is. At what point would you integrate them into this into the mods that you're planning on doing?
Well, we're not totally sure of how to get an airworthiness certificate, but well, we mainly use technologies that would achieve a technology readiness level as high enough in 2025, so we are pretty much sure we can use it, we can plan to use it now. And yeah, basically about the engine, we know that it's going to probably be on the A330, and I think it's the 747. They plan to use the new Rolls-Royce UltraFan. And for the other improvements, it's all studied by companies. The tiny holes in the tail is studied by, I think it was Boeing. What else? The advanced composites is already a study made by NASA engineers. So, well, we don't know how to get an airworthiness certificate, but we are pretty sure that we can obtain it with the improvements that we've done.
How long do you think it would take you to get the airworthiness certificate?
I have no idea.
Well, I have a question. Microphone moving? First of all, thank you very much. Very good presentation, good proposal. I'd like to go back to your fuel weight savings, which are actually, I find staggering. 40% fuel savings. You really beat out the competition, the Boeings, the Airbuses, the Bombardiers, Rolls-Royce, and the Pratt Whitneys of this world. How do you, usually in new product designs, you can get 15, 30%, maybe the most. Could you go back and explain how you get these incredible results in terms of weight saving?
Well, based on the A310, based on the A310, it was estimated that the specific fuel consumption of the UltraFan was 25% lower than that of the existing Trent 772. So basically there's a great improvement on the engine. Then we get a structure mass based on composite, knowing that the wing and fuselage make up about 40% of the weight of the empty weight of the aircraft. Then we get the 10%, and by multiplying all this, we get 40% roughly. But this is estimated, but I think, in my opinion, we're in the good range. So, and so yeah, so by saving on fuel weight, we save on empty weight, and then by saving on empty weight, we save again on fuel weight. So yeah, that's how we got there.
We have just 5 minutes perhaps for 2 more questions.
Last point, actually very good presentation. What I like the most, I'll just mention points that really I liked a lot, and my colleagues probably like very good questions. I like your systematic approach. You had your idea how to discard some design possibilities and get to the one that you, as you understood, was the most efficient, proven configuration, which I think is extremely important when you're obviously you need to fly, but you need to be loaded, unloaded, you need to use existing infrastructure. So having an aircraft like similar to the A310 obviously is, you can, airport or even the cargo place are going to be an end-of aircraft, and you have already everything in place to load it properly. So very, very good point. I like also your idea of removing the windows in terms of weight. That that's a gain.
Yeah.
Absolutely. Absolutely, that's that's something that we have to make for an aircraft that flies with a passenger into it, but for cargo, absolutely, very good findings. That's it. So congratulations.
Thank you.
A final word from Mr. Mitchell, perhaps?
Indeed, a good presentation. It's really interesting to see how you give a second life to this aircraft which is aging away. But I'd like to ask, have you thought of the evolution of what's coming next? So you're taking a pretty old design of an aircraft. If you take a more unconventional architecture today, so you have no improvement plans into the future. But have you thought of that? How are you going to improve it further? Because you'll get the most of your improvements already here. What's next?
Well, as I can't remember who, I think it was Mr. Marandola pointed out, oh no, it was Mr. Benevins, the aerodynamics could be a good start. Improving the aerodynamics could be a good start, and then I guess we can just follow the technology, because aircraft engines keep improving years after years, so in 2025 we'll already hear about the next engine will be even more fuel efficient. So I think aerodynamics could be a good start, and then yeah.
Thank you very much.